Hey guys, today we are on pages 21 through 23 in our notes. We're going to talk about how to write an equation or just review how to write equations from graphs and to talk about horizontal and vertical lines because we haven't done that before. And then we're going to do some problem solving with word problems. So we're on page 21. Go ahead and get those pages out and we will go ahead and get started. So to write an equation, we need two main pieces of information. We need the slope of the line, the steepness, which is your rise over run, okay? And we also need the starting point, or we call that our y-intercept, okay? If the graph is proportional, we know that the equation can be written in the form y equals mx, because proportional relationships always start at the origin. However, if a graph is non-proportional, we can write the equation in y equals mx plus b, because that plus, that extra added or subtracted number, is the starting point. Now, something we haven't talked about is horizontal and vertical lines. So here is a horizontal line, okay? We can remember that a horizontal line has a zero slope, okay? So because of that, our y value is always going to be constant. And when we have an example like that, we will talk about what that is. Therefore, equations of horizontal lines will always begin with y equals, okay? When we have a vertical line, which is something that is kind of strange because our slope is undefined, that means that our x values are always constant. Again, when we have an example, we'll talk about what that means. Therefore, equations of vertical lines will always begin with x equals. So vertical lines are the only time where it doesn't look like y equals mx plus b or y equals. Vertical lines will be the only time we have an x equals equation. But when we actually get to a problem, we'll talk about that some more. So just a nice little review. We are going to write these equations. So I always start off with the starting point. So on the starting line on the y-axis, the y-intercept is 4, okay? And then we have to find the slope. So I'm going to find another good point. So I think that that's a good point. And I have to find the slope or the rate of change. So my scale is going up by 2s. So this is going up 2. And this is going over by 1s. So this is a slope of 2 to 2. And a slope of 2 to 2 is equivalent to 1. So our equation is y equals mx plus b. So our slope is 1, and our b value is 4. Obviously, you do not have to write the 1 on the x, but you can if you'd like. Then finally, is this graph proportional? Proportional means it starts at the origin. This is the origin. The graph is not on the origin, so this is a non-proportional equation. Okay, for the second problem, okay, our starting point on the y-axis is -4. Okay, then to find the slope, we need to find another good point. So here's another good point. You could also use one up here, that's fine. Okay, my scales are going by 2s, so I have to go down 2, 4. And then my x's are going by 2s as well. So I'm going to the right 1, 2, 4, 6. Okay, so my slope is down 4, right 6, and I can simplify -4 to 6 and make it -2/3. So my equation could be written as y equals -2/3 x minus 4. Again, asking myself, is this proportional? Asking myself, does it start at the origin? No, it does not start at the origin, so it is not proportional. All right, on page through 22, we will see we have our first non-diagonal line. So this is a horizontal line, okay? So I'm just gonna write some data points off to the side just so you guys can kind of see what's happening, okay? So I'm just gonna write a few data points or ordered pairs, okay? So I see -2, 4. I see 0, 4. And I see 2, 4. Okay. So in the notes earlier, it said something like, if the horizontal line, the y value is always constant. And what I mean by that is when we think about our slope, okay, these are going up by zeros as these are changing. And if you have a slope of 0 over a value, That means it has a slope of 0. Okay, the y-intercept, we do have a y-intercept. It is 4, so it does have a starting point as we're used to. And so the equation would just be y equals, we have no slope, so you could write 0x. I'm going to write it over here, y equals 0x plus 4. But if we don't even have a slope, we really don't even have to write that. We would just simplify it down to just y equals 4. Okay. Is this graph proportional? No, it is not, because it is not starting at the origin. Okay. This one over here, we have a vertical line. I'm going to write horizontal over here. Okay, so I'm just going to, again, write some ordered pairs that I see just to see the relationship. Okay, so I'm going to pick right here, and right here. Okay, I'm just picking random ones. So as an ordered pair, that would be -6, 6, -6, 0, -6, -2. And again, you could pick different ones. But if I figured out like kind of what the slope was, these are changing. My y values are changing, but my x values are staying constant. And so if we actually calculated this slope, this would be an undefined slope. Okay, so the slope is actually undefined. Okay. When we ask ourselves what the y-intercept is, this line's never crossing the y-axis. So there is no y-intercept. So this is just one of those really weird equations that kind of don't fit the norm. So I always like to remember the x value is constant, therefore the equation is x equals. This is the only time really a linear representation will be an x equals equation until you get older. Okay, so the x equals, and what I do is I just look and see, okay, x is always -6 in my ordered pairs, or it's always at -6 right here. It's crossing actually the x-intercept. So my equation is actually x equals -6. Whereas this one, y equals 4, was the y-intercept. This one is the x-intercept, which we don't really do anything with x-intercepts until you get to algebra. But this equation would be x equals -6. And so I'm going to write an x-intercept, and that's how we kind of figured that out. Is this proportional? No, it's not crossing the origin. Okay. Number 5 says, which of the following situations could be modeled by the graph? Okay, so I want you guys to pause and go ahead and pick which one you guys think it is, and then your Edpuzzle will ask you to pick. All right, so I like to just read the problem. I like to just look at the graph. So it looks like it's starting at 100, whatever 100 is, okay? Positive 100, and then it looks like the slope is going down. So I need to find another good point. And it looks like it's going down 10 every time we go to the right 3. So the slope is -10 to 3. So you have to figure out which story problem would match this, okay? Elena has $100 in her bank account, which that sounds about right because it looks like she would start with $100, okay? And every 3 days, she saves another $100. Well, when I think of saving, I think of adding money. So while this is very close, it has the right y-intercept and it has the right values of the slope. This one was a negative because it was going down, so it's definitely not A. Okay. B says Hunter weighs 100 pounds. Okay. And his goal is to gain weight for football. He gains about 10 pounds every 3 weeks. Gaining means to add every 3 weeks. So again, this is very similar to A. It's very close, but our line is going down. So it looks like our answer should be C if we did it all right. Okay. Dawn's pond is 100 meters deep. Okay. But her city hasn't received much rain. As a result, the pond level is going to decrease 10 meters every 3 days. So this matches the equation that we wrote because it starts at 100 and it's going down 10 every 3, whatever. For this case, it could be 3 days. So C is the correct answer. All right, part 6, it says to create your own real-world situation that can be modeled by this equation. So I'm going to go ahead and write this, okay? So this one starts at 2, okay, positive 2. And then we need to find the slope. So I'm going to pick another good point. So the slope is going up from 2 to 4, that's up 2. And it goes over 6. So 2 over 6 is the slope. I'm going to simplify that as 1 to 3. Okay, so in this Edpuzzle, I want you guys just to try to write a real world situation that could be represented by this. Okay, after you guys have done that, we're going to be on page 23. We're just going to look at story problems and write equations, and then hopefully be able to problem solve and solve equations to help us understand some points in time. So Miss Ralston works the gate at a basketball game and receives $5 every minute. She already had $40 in the money bag. Write an equation to represent the total amount in the money bag B after any number of minutes M. Okay, so we can think about what the initial value is. So the initial value looks like there's already $40 in the bag. And then we can think about the rate of change, and it looks like it is $5 a minute. Okay. We have used other words for initial value. That is just our B value, our y-intercept. And the rate of change, that is also just considered your slope or your rate. Okay? So your equation, we could write it generically speaking as y equals 5 a minute plus 40. Okay? It did want us to use different variables, so we could also write the money in the bag. The bag equals 5 a minute plus the 40 that I started off with. Okay, a mosquito population is currently estimated at 28 million mosquitoes per square mile. A spraying company will decrease the number of mosquitoes by about 2 million mosquitoes per square inch every hour. Write an equation to model the mosquito population after any number of hours h. Remember to define your variables. What does the slope and the y-intercept represent? Okay, so I'm just going to write m. So m is my slope, and b is my y-intercept. So I'm going to start off with what it begins with. So it begins with 28 million mosquitoes. Okay. And the slope says the spraying company will hopefully decrease the number of mosquitoes by 2 million every hour. Okay, so the slope seems to be going down 2 million mosquitoes every hour. I guess I don't need to write every. Okay. So an equation that we could write, a generic equation, would be y equals negative 2x plus 28. Okay. Or we could also write it using the p and the h. That they're asking the population equals dropping 2 million an hour, but starting at 28. Okay. Then it says to predict the mosquito population after 5 hours. Okay. So I'm going to show you guys a couple different ways. I'm going to show you guys with a table, and I'm going to show you probably a quicker way using an equation. Okay. Both are correct. You just kind of have to pick which way works the most effectively. Okay. So 0 hours, basically when we started, the population was at 28 million. After 1 hour, it says it'll decrease it by 2 million mosquitoes. So it should be down to 26. So basically we need to figure out 5 hours. So I'm going to go all the way down to 5. Okay. And every hour I'm decreasing by 2 million mosquitoes. So I'm going to keep going down by 2. Okay. So it looks like at 5 hours there should be 18 million mosquitoes. Okay, so that is one way. You did have to make a table. You had to know how to use your slope and your y-intercept. Another way would be using just this equation and substituting that number 5 into the number of hours. Because if I am decreasing the number of mosquitoes by 2 every hour for 5 hours, that means I'm really decreasing it by 10 million mosquitoes. I started off with 28 million. So 28 million minus 10 million would be a population of 18 million mosquitoes. So those are just two different ways that you guys could problem solve to figure this out. Create a table, or just problem solve, multiply, and then add in the 28 at the beginning. All right, the final problem. Ace Car Rentals charges $20 per day plus a $10 service fee to rent one of its compact cars. Write an equation to model the total cost of a certain number of days, D, at Ace Car Rentals. What do the slope and the y-intercept represent? So M equals and B equals. Okay, our initial value is this $10 service charge. So that's my initial value. And the slope is the $20 per day. So the equation could be y equals 20x plus 10. Just making sure we're comfortable with using other variables besides x and y. It says the total cost equals $20 every day plus 10. Okay, then the last two questions, it says predict the total cost for 7 days, and then how many days would it take for the final charge to be 370? So I'm going to kind of make a table, and I'm going to kind of make it down this way just because I don't have a lot of room. Okay, so my x is days, and my y is cost. Okay, so I need to figure out for 7 days, so I'm going to start at 0 days and go up to 7 days. Okay, so the service fee is $10, so the starting cost is $10. Okay, for 1 day, it would charge me $20 plus that $10 service fee, so that would be a total of $30. For 2 days, it'd be $20 a day, so it'd be $40 plus the $10 service fee, so that's $50. 3 days, $20 a day, that would be $60 plus the $10 service fee, which would be $70. And then that would be $90. 110, 130, and 140. So for 7 days using a table, it looks like it would be 140 days. $140, excuse me. A quicker way, if you feel comfortable with it, is just using the equation. If the cost is equal to $20 a day, so for 7 days, that'd be $140 plus the $10 service charge. And I made a calculation mistake, shocker. That would be 150. Okay, so the cost would equal $150 for 7 days. Now, the second question says, how many days would it take for the final charge to be $370? Okay, so we're at 7 days right now and it being 150. So it looks like it's gonna be quite a few. So I'm just gonna write a bunch of numbers. Again, I'm gonna show you this way, and then I'm gonna show you the equation way, which you might think would be a little bit easier. I'm just gonna go up to 20. I hope it's under 20. So, 8 days would be 170, 190, 210, 230, 250, 270, 290, 310, 330, 350, 370. So $370 looks like it takes 18 weeks. Now, that was making a really, really big table, which it does work, and you just have to pick a way that would make the most sense to you. Now, a quicker way could be, I need to figure out the number of days if I know that the final charge is $370. So if the final charge is $370 at $20 a day plus the service fee, I'm basically just going to take out the service fee. So now I'm dealing with $360, and $360 at $20 a day would be 360 divided by 20. So that would be 18 days if I were to divide that. Okay. So to me, solving an equation is a lot easier, but if you don't know a place to start, you could just create a table. Okay, so for today, guys, there is a Delta Math question, a couple Delta Math questions, and you're basically just going to be writing equations from graphs, just making sure you feel comfortable. And then tomorrow, we're going to deal with word problems and horizontal and vertical lines. I'll see you tomorrow.